Question 7, we're dealing with the binomial distribution, n is 12. The probability is just given as p to start with, but in part A of the question, we are told that p is 0.25. So then we can rewrite the distribution as the binomial with n as 12 and p is 0.25. We're then asked to find out the probability that x is less than 5, so strictly less than 5. Well, if it's strictly less than 5, what can it be? Well, it can be 4, or 3, or 2, or 1, etc. So it can therefore be less than or equal to 4. Now, 12, 0.25 appears in your binomial, cumulative binomial probability tables and the formula booklet there. And so for this, n is 12, p is 0.25 there, and we're looking for less than or equal to 4, so put the ruler on the 4 row there, look along, make sure you're in the right column for 0.25 there, look down, and it's 0.8424. Okay, so 0.8424 is then the value we need, and that's done. Okay, part 2. This time we're looking for the probability that x is greater than or equal to 7. Well, if it's greater than or equal to 7, that's kind of the wrong way around. We need it to be a less than or equal to problem. If it's greater than or equal to 7, what can it be? Well, it can be 7 or 8 or 9, etc. Okay, what cannot be? It can't be 6 or 5 or 4, etc. So, that's to say that it can't be x less than or equal to 6. So the probability that x is greater than or equal to 7 will be 1 minus the probability that x is less than or equal to 6, because total probabilities add up to 1. Okay, so probability that x is less than or equal to 6. Okay, so this time we're going to get the table again. Get to the right table. N equals 12. Row 6 this time. Make sure we're still in the column 0.25. And so this time then the cumulative probability is 0.9857. 0.9857. So slot that into there, 0.9857. 1 minus 0.9857 is going to be 0.0143. 4 decimal places. Okay, in part B, this time we revert back to probability of success simply being P. It was only in part A that probability of success was defined to be 0.25. So we've got n is 12 and success probability is P. But we are told that probability that x equals exactly 0 is 0.05. Now this is quite nice because if we use the formula for that, we get 12C0 times by probability of success, which is P to the 0, times by probability of failure, which I write as Q, or you could write as 1 minus P to the power of 12. Okay, so no successes, 12 failures, and so 12C0 there. Now 12C0 is 1. Anything to the power of 0 there is 1 as well. So we're simply left with Q to the 12 equals 0.05. How do you solve that? Well, you need to take the 12th root of 0.05. Okay, so to take the 12th root of 0.05, get your calculator out. The 12th root button is there just above the power button. So 12th root of 0.05 is 0.77907, etc. Okay, keep that full calculator value because now Q, remember, is the probability of failure, so therefore the probability of success P will be 1 minus the probability of failure. So 1 minus that, so 1 minus the answer, 0.220922, etc. So to three decimal places, 0.221.